first video to the YouTube. So I was thinking that I will really shorten this part because I will just, it's big data. Actually, you don't have basics about relational data, and now I should be speaking about big data. So I will kind of make here some, I will really shorten this part and go just through three or four main things. Mostly for Simon, that he would understand level up. So big data processing is actually the same process. We need to ingest data from different data sources, the same as in the analytical data warehousing system. We do need to do some data ingestion, we need to do some data storage, and this data ingestion and data processing can be done two-way, in batch processing and stream processing. Batch processing means that we are actually collecting large amounts of data and we are running one massive processing on the huge data set. In the meantime, we can process the data that has newly arrived to our system, which is stream processing. And then when we finish this processing, we can again push that data to analytical data store or some front analytical part of the system, which does the same analytics and reporting and as it was done from the data warehouse, which means Simon, which software did you use for business intelligence? Tableau or Power BI, or what have you used?
At this project, we used Visual Studio.
Visual Studio for programming, but for the analytical end as the final, which tool was it?
We was making dashboards and some other charts also at this Visual Studio.
Uh,
So awesome.
Also, because there are other solutions. One of them is not like this. This one is probably one of the most used ones, but it's kind of free only. I need to go through the process of registration for students. So here you can see I'm trying to retrieve some. Okay, so you can see that actually Tableau dashboards are collection of some aggregated data and visualization. And Tableau is probably the leading one. Besides Tableau, it's also Microsoft Power BI software. Result looks pretty much the same. Dashboard is always visualization of the different charts of data. Here is another BI visualization, and the third solution that is also okay, and it used to be the leading on the market, but now they are kind of lagging behind and Tableau is taking over. The third provider is MicroStrategy. And if you see again, dashboards are looking the same. And my students used to use both of these, and they never agreed. Some of them preferred MicroStrategy, the others preferred Tableau, which means there is no need to hard code all this visualization. Uh, would you like me to send you a link or two? So Simon, if you want, you can try this one. I think it has a free trial.
Mhm. At this semester at my home university, I have one lecture which I must pass from Poland, and at this lecture we are doing some charts at these tables and dashboards.
With Tableau
Tableau.
or some other software.
Oh, with Tableau, we started with Tableau.
Okay, that's good because I wanted to suggest, because you're
Mhm.
kind of ahead of other, that maybe you can by yourself check Tableau. I think it's going to be useful, but you are already doing it, so you can actually use Tableau for the visualization here if you want to practice.
Okay.
Uh, we can discuss that later. Uh, and Tableau, I think Tableau is the smart decision. I prefer it over Power BI, but if you have already Microsoft license, then you can use Power BI. And I was developing in this MicroStrategy, and that was my first choice. They do have some really nice visualizations. Can you see this one? So they have some advanced visualization capabilities, but maybe you don't need that. And my students are actually coding in Python. They prefer that at the moment. So this analytics and reporting part, when I'm talking about it and dashboards, you should have something like Tableau in mind. Now I have some other concept to explain, that is mutable and immutable data. This is really important for the understanding of big data processing. In big data, I said that we are collecting images, texts, sensor data, embedded data, IoT data, things like that. And this data is usually collected, processed for analytical purposes, and never changed. Let me explain you this way. Let's say I am collecting all the photos from Instagram that somebody has posted with hashtag of my product. Uh, I will analyze these pictures, maybe find in which surrounding my product was photographed, but I will never go and edit these photos. I will collect text below that was written with this photo, but I will never go and change the text because it's really not important, which means that when I'm collecting big data, I'm usually collecting the data that will be only taken and stored in my system for analytical purposes and processed with some advanced analytical features, but never changed. And this means that the data is immutable. Uh, And this means that we don't need to update or delete content of this data. We are just adding new ones as they arrive, which is completely different from what we are doing with relational databases. With relational databases, we are doing with mutable data. And mutable data, now for you, Simon, is something that you need with SQL to assure that you can insert it, select it, update it, or delete it. You need to perform all we call it crude operation, but create, delete, and everything. And if you want to do that in the secure way, database management system needs to assure that database is in consistent state, that all records has been recorded, that no record is lost, connection to the other record. When you delete, all appearances of that record needs to be deleted, and so on and so forth. And this is the from the engineering part, that's really difficult to program and to assure. This is why database management systems, let's say Oracle or Postgres or some database management system, is actually doing this business for you. And managing of mutable data, where data can change, and business data is mutable because data items are changing. It needs to be done in the relational database, because the relational database is the best engineering solution that we have for the mutable data, which means data that is changing, updating, deleting, or keep up the latest value of one record. But this is not the case with big data. As I explained, when we are collecting images from the Instagram, we are not going to change anything in these images. We need just some computer vision system that is going to process these images. We need, when we are collecting, let's say, tweets, we just need to find polarity of these tweets. We are maybe not even interested in the text that it's written in these tweets, and we are never going to edit these tweets or do anything with it. And this means that when we are dealing with big data, we are actually dealing with immutable data. And that's important because from the technical point of view, when we are dealing with this different kind of data with such huge quantities, we will not be able to assure all functionalities that the relational databases have. This is why we have developed other storing possibilities, meaning no SQL databases, and meaning data lakehouse, and other technologies that are capable of storing this raw data in some other formats. Is that clear? Simon, for you, I hope it is. I want to check with Anya.
More or less, yes.
Okay. Jakob, still alive.
Yeah, of course, of course.
Okay, good. Because it's really not point, it's only three of you. So I can really adjust the level. But here we have different backgrounds, so I'm really trying my best um to deliver lecture that is useful to Anya, to Simon, and to Jakob at the same time, which means that I'm really improvising, talking out of my head, not out of the lecture that I have prepared. But I hope now that this concept of mutable and immutable data is really okay. And here Last year I checked what ChatGPT is suggesting as examples. Uh, so here we have some logs. Let's say, have you ever seen the log on the Moodle? I will do this. So what you are seeing now is the log what has happened on Moodle. Uh, it was pretty much uh, Anya was uploading, I was grading, Simon was logged in, and so on, Jakob, and pretty much all three of you that are today attending lecture, you were also active on Moodle. And this is something that is logged. For instance, here I can see that Jakob actually used the link for online lecture, and this happened from his IP address. And before he viewed the course and so on, and here he probably viewed the grade that I gave him. And these are all events in the past. They are only appended to this log. And they are never going to be changed. So for instance, this record when Jakob checked the grade that I gave him is never going to be changed. That means that this is immutable data. And logs are kind of data, they are always appended. Would somebody care to log in to see what is happening with the log? Just open one PDF or something, and I will refresh it. Okay, you see now it's Anya actually checking something, and we can see that Anya has done something on the Moodle at 6:18:37, which is current time. And now if I refresh it again, probably we will see that after Jacob has done something. But I'm not able to change any of this record. I can only see it. And this is kind of how logs are doing. And this is example of immutable data. And ChatGPT suggested that blockchain data is also immutable. And now I need to skip a large part. This is going to be too difficult for you. I will try to explain it. So I will go slowly and try to explain it that Anya can capture the essence of what's the story here. So when we are dealing with big data, we are dealing with data that has a huge quantity. Let's say we are dealing with terabytes and terabytes of data. And if you have one server like this that has limited memory and limited processor, uh, you cannot process this quantity of the data because you cannot add enough memory and enough processors that you can process all this data. Let's think that big data was actually something that first started at Google when Google invented some programming paradigm that Google will be able to index all web pages on the internet. And we have seen that there is over 57 billions of pages, probably more currently. And this is impossible to be done on the single computer. So we need to change how we are processing this data. And now I will go skip forward to this architecture that is actually architecture that has started for big data. So what we have here, we have a lot of commodity hardware servers that are interconnected in one huge cluster, which is usually called a Hadoop cluster. And why is this working and the other not? Because we can add as many computers as we want into this structure. And this every block that you see is standard server that you can go to the first shop in Copar and buy one. You just need to put, okay, it's not easy. You need to put some software and you need to have money to buy a lot of them. And if you can connect lot of servers that you can buy in the local store in Copper, you will be able to process this big data. But then you will need to do with something that is called distributed computing architecture. And software that was like operating system for this kind of architecture is called Hadoop. Now I will stop and ask if this is clear, Anya.
Yes.
Okay, good. I'm succeeding in being in simplifying things. But this is really important as a concept, which means that big data is not only the philosophical concept, but we needed to change how we are processing data. And I will go now back to the first example, and this is usually not this, but this one. The first picture is usually one big, really powerful server that is processing the relational database or data warehousing system. It can store a lot of data with a lot of disk. It can have many processor, but it has upper limits of what it can store and what it can process. And this kind of processing was actually something that was appropriate for information systems and maybe early stage data warehouses. Now data warehouses are also made in this distributed architecture. The second important thing is microservice architecture, when we actually have one monolithic system, let's say software, that is accessing the database. We don't like that. We want to have this big software divided into a lot of smaller parts that can communicate with each other, usually via APIs, API calls. And this is the modular architecture, because this service is connected to this one, but they are interconnected with API calls. And when team who is developing this service in the middle is changing something, all other services do not need to be changed. And this is really important because this modularity actually enabled development of really huge software system. And to be honest, here I will show you something else. Okay, I will show you this one. Actually, we are never mentioning Bezos, who is the main guy in Amazon. But actually, Bezos is the one that who actually architected this solution, and this is snapshot of his mails that he sent to all Amazon developers in 2002. Actually, I think that you are pretty much born in year 2002. Am I right? Maybe 2000, 2001.
Well, I think we are all older.
You're
I,
older. Which year
I'm
are you?
I'm 99.
99. Okay, a
Yeah,
little bit older.
yeah.
Simon,
I'm 2001.
2001. Okay, almost got it. And
I'm
Jakob,
2000.
2000. Okay, more or less that year. But this was visionary, and in computer science, we are really appreciating Elon Musk at the moment and so on, and Bezos is staying behind. Actually, he is very, let's say, not exposed in the public. But this email, I will go through it. It was really philosophy of microservice architecture that is main software architecture at the moment. What did he wrote? All developer teams must expose their data and functionality through service interfaces, APIs. Teams Amazon teams must communicate with each other only through these interfaces. There will be no other form of inter-process communication allowed. No direct linking, no direct reads, no shared memory model. Shared memory model is the first one that I showed you. No backdoors whatsoever. It doesn't matter which technology are they using. All service interfaces, without exceptions, must be designed to form the ground up to be externalized, which means that after this email in 2002, they put all the data and services behind APIs. And this enabled the loose coupling of really huge system, which is beneficial. When you have this loose coupling, each component is kind of uh, part of the bigger picture. But if you change something in this component of the software, you don't need to change all other parts, which means that you can build agile and really huge software. So this was kind of revolutionary also. So first we had the Hadoop and development of Google file system, which enabled this distributed processing. And then we had this Bezos philosophy of microservice architecture. And maybe for manager, it's also important now. Majority of what I'm talking about is not stored locally on your computer, but it's stored in the cloud. And cloud, there are three main cloud providers. First, I think is Amazon. Amazon is not anymore. I think Amazon is much more of the cloud service provider than of the retail company. Then we have a Google Cloud and we have Azure Cloud from Microsoft. There are also some other solution, but this is majority of the local market, I think. Jakob, Simon, do you have in Germany or in Poland some other important cloud providers?
I don't think. I think that the most popular is the cloud Microsoft in
Microsoft in Poland.
the big company. Mm,
Here, majority of the companies are on Amazon, uh, but some are also on Google Cloud. Uh, why is this important? Now I will step back because I talked about these architectures, and it turned turns out for companies that it's easier to pay these cloud providers to um, use their servers, their storage, and instead of buying commodity software and installing all this software and hardware uh, in your company's basement, you are actually buying the service at the cloud providers. It can be hardware, it can be storage, it can be software, many things. And companies are actually pushing all their, I would say, information system and also analytical systems to the cloud. And we have different solutions in different cloud providers. For instance, in data warehousing, it's really important Snowflake database that is also in the cloud. This one. And now Snowflake has, I think 2 days ago, made agreement with Mistral Artificial Intelligence, which are the only European provider of large language model. And Mistral is going to provide the generative AI functionalities to Snowflake. But this is not what I wanted you to see. Actually, Snowflake is the data cloud. Workloads can be different. You can have also data lake, data warehouse, and so on, also here. So, lot of, let's say, banking. For sure, I know that Erste Bank, uh, some Croatian banks which are not Croatian but Italian are all actually using this Snowflake. Have you heard of this Snowflake before, Simon?
when I was working at my internship in company, which
Mm,
was named Silky Coders, and this is a daughter company of LPP. So I think that there was no one cloud, there was some clouds, and there was Google Cloud GitHub, Google Cloud Platform also.
mhm.
The mail was at Microsoft, and I think that there was Snowflake, but only the seniors and employees like that was using it. I was not using it,
Okay, of
but I.
course, because it costs money
Mhm,
using cloud.
mhm.
Uh, and you need also to understand some about cloud services and how to use. I'm sending you here the link just to check it later if you want. But this Snowflake is some, I would say that they are taking the majority of the analytical segment in these, let's say, traditional businesses like banks, insurance companies, and things like that, because they do have this merge between traditional information system and analytical really nicely done. And why I'm talking of the cloud? Because when you're pushing to the cloud, you need to think about several things. But first is security, and Amazon is actually guaranteeing you security of the cloud, but not security of the content that you are putting in that. They are actually protecting the infrastructure, and they are providing you a service agreement that your cloud will be always available, not going to be down, and so on. But users that are using the cloud are responsible for the security of their software and data in the cloud. The second thing that is maybe really important for management, that cloud, if you have the huge IT in your company, each team is actually hosting their part of this microservice in the cloud, and they are buying these cloud services independently. And for big companies, cloud can cost a lot of money, which means that now we have something that is called financial operations. Actually, something that is trying to financially maximize the business value of the cloud, which means they are trying to cut the costs and to wisely use cloud infrastructure. I will send you this one because I think this is really important from the management point of view, because companies that are heavily using cloud are now turning into these FinOps, different kind of these FinOps solutions, because they can save money if they centralize the buying of the cloud, because buying of the cloud services was decentralized among teams, and when they kind of manage to do this centrally and do it with analytical background, it's been reported that they can save $500,000 per month, which is extremely lot of money. So from the for students of management, I think maybe it's good to be informed about this, because this is the new thing that this FinOps was not. So here you can find a lot of different things, but something is really slowing down. So maybe some use cases and things can be here. Frameworks, certifications, and so on. Because this is not only understanding the technology, but also understanding the business decisions and cutting the costs. This is actually quite new, and it hasn't been around for a long time. So for the management, I think maybe understanding how much costs, how should I put it? From the one side, we are actually running our businesses with information technology, with software, and companies are data driven. On the other side, the cost of data driven business is not small, which means that we need to maximize outcome of our analytical and IT efforts. And at the other side, we need to cut the costs. And if half of the companies are already in the cloud, that actually that propel development of these financial operations to as the philosophy of how companies can start cutting the costs for the cloud. Is that clear?
More or less.
Okay. Maybe that's Simon for you something to take a look because you already have the technical background. So I just need to take a sip. So what do I have here in this lecture? I will not go through everything because it's going to be too difficult. I want to just explain these two concepts. What does it mean, batch processing and stream processing? Batch processing is processing huge data, really huge data sets, terabytes to petabytes. When you think of batch processing, think that Google is indexing web, and time between and this batch that is processing this huge quantity of data can last for hours. And during this batch processing, new data can arrive. And this is why we need stream processing that is capable of capturing and processing data while the big batch query is working, which means that here I have a stream processing architecture that is processing smaller quantities of data in much faster periods. And big data architecture started as this architecture, which is Lambda architecture, where you have the batch layer and streaming layer, and then some analytical serving layer. And streaming layer serves the data with the lowest possible latency. Uh, some it can be some NoSQL database or something like that. I haven't talked about NoSQL databases, but beside the relational databases, uh, we can have also big data databases. NoSQL databases where you don't have this strict data model. And so here we go. So this is not a relational data model, but it's really very simple. It's key value store where we have only identifications and then value, whatever value is. Then we can have column store, which are actually storing columns of the huge data warehouses. We can have a document store where actually we store documents, or we can have some graphical data, which is kind of interlinked or connected data. And this is going into the big data architecture. I want to show you example of graphical data. So here is one person, and this person has a relation with other person, and this person is driving, this person is owning a car. And a really good graphical database is Neo4j. Um, It can be used also for storing of the knowledge graph in the company. And have you worked with any NoSQL database, Jakob? Simon, pardon.
With that, no.
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 Me neither. Me neither.
Okay. So maybe next time, if you want, I can cover the concepts of NoSQL databases, because it's not only this. I now shortly went through 4, and you can see that these databases are actually not general one, but they are fit only for one kind of the problem. And for relational databases, they are, let's say, general. And here each kind of database is fit only for one kind of the problem. Some are for processing really huge amount of data in data warehouses with data stores. Then this key value is actually also for processing massive data on Hadoop with MapReduce programming paradigm. And graph data is actually representing data as knowledge graphs. But that's not everything, because beside this, we do have also the vector databases. And these vector databases now are very much linked to the generative AI. So here I have a representation. I have some key, some numeric identifier, and then I have the value, whatever this value is. It can be image, it can be document, it can be some data. All then I can have keys, and I have whole documents behind. That's MongoDB usually. I can have some graphical structure, or I can have the vector in the high dimensional space. Have you had linear algebra as the mathematics? Do you have background in linear algebra? Have you worked with matrices and vectors and things like that? Jakob, Simon, you two probably have had
Yes.
that. Yes,
Maybe I have it at my first year at bachelor, but I don't remember.
you don't remember. Matrices and so on. Anya, you probably didn't have that,
No,
because it's not something that business students are doing. But
no.
why is I'm asking? Because these vector representations are used with these neural networks, where it input can be transformed in this vector n-dimensional vector space, and then we can retrieve data semantically, which means that when I push some content through embeddings and get this vector, which are numeric representation of data, and content can be text or images, then I can find similar things really easy in this vector database. And vector database are the main technology for storing knowledge when we are developing applications with large language models. So here is example. So first I'm taking, let's say, all the PDF documents that you have in company, all meetings, all contracts, everything that is in document. I extract text from this PDF, and then I'm putting these all documents, parts, let's say sentences of paragraphs or your PDFs, into the vector database. And here is your local database of your local knowledge. And then you need to ask a large language model about something that is not written in the large language model, but is something that is written in your internal documents. You don't want your intellectual property to go into the large language model. So what are you doing? User is querying. This query is also put into the vector, and then you go to the vector database and find similar vectors to this one, which means that now you have extracted or retrieved the relevant part of your PDFs, and then you have the facts. And when you have the facts that are relevant to the query, and these facts are your internal facts, not external, then you put this data to the large language model, and then you have the nice response in your language. And reason why vector databases are developing so much is actually this architecture. When you are retrieving, uh, actually pushing generative AI to generate responses, but with the facts that you have in your internal documents. And vector database is the fifth kind of NoSQL database, and these vector databases are really new. Embeddings, and so that was already present before, but as vector databases has actually, I think, year 2023 is the year, or it was year when the all databases actually started. And I will provide you this link. Not here. Here is the list of all vector databases that are present in the moment, with some really nice filtering and search. I will push this also in the chat. Maybe you would like to check it. So to recap, from the non-relational technology databases, in this analytical processing stack, we can have something that is called NoSQL, meaning not only SQL databases. It can be either key value, it can be column store, or it can be graph store, document store, or vector store. And all these kind of NoSQL can be put somewhere here in the serving layer, because now you are dealing with external data with lot of images, texts, and things like that. And it all started with this Lambda architecture, where we have the batch and streaming layer, and that later started to be only streaming layer, where what streaming means that we are only in real time. Remember that I said that the big data is coming at high speed, high velocity, and now we have different software that can produce these streams really fast, Kafka, Spark, and so on. And actually, when each record is coming, we can do some analytic processing with it and push it right to the serving layer, which means that now we are capable of doing analytical systems in a real-time data processing that are really collecting the data from external sources, let's say Facebook or Twitter, and putting this data into your analytical architecture. Was that too much, or it's clear? So I will stop recording right now.